So let's talk about electronic configuration. For electronic configuration, the first thing you need to know is how many electrons does that atom have, right? So when I said the electronic configuration of neon, the first thing we need to ask is how many electrons does neon have? It has 10. Now there are some rules that govern how we arrange electrons. This is part of what was discussed in your book. And I'm going to write down one of the rules here. There's something called Horn's rule, and there's something called Pauli exclusive principle. So here's how it goes. 1s is the first one that electrons are found in, the first level we're dealing with. And then you go to 2s and 2p, and then 3s, 3p, and 3d, and then 4s, 4p, 4d, and 4f, and then 5s, 5p, 5d, 5f, okay? And then it goes on one more for 5, but we're not going to go that far. In this class, we're really going to stop around there. So it's important we know the first 20 elements and how to write the electronic configuration of all 20. Eventually, that's part of what we would need to happen. So here's one of the rules in chemistry. Very interesting how this flows. When you write the electronic configuration of elements, the first two elements, hydrogen and helium, so if I say what's the electronic configuration of hydrogen, it's just 1s1. It has one electron, it's found in the s orbital, that's the answer, right? There's the s orbital, there's the p orbital. These different orbitals have different shapes that they take. And these different shapes, so when we're looking for these electrons, they're found in certain, pieces of this shape that we look at. So s orbital, p orbital, d orbital take different shapes. So this is like a p orbital here. This is an s orbital, like a sphere sort of distribution. So when we look at, some of this is discussed in a quantum mechanics course, which this is not a quantum mechanics course, so we're not going to go into detail there. What we need to know here is more of just the systematic way to write electronic configuration. So if it's hydrogen, it has to be 1s1. If it's helium, it'll be 1s2, because hydrogen is the first element, helium is the second element. So we go with the 1s orbitals first, and then we come back around and we do this. So that means we go with the 2s orbitals next. After we do the 2s orbitals, we come back and we do the 2p orbitals next, and then the 3s orbitals. And then we do this again, and then we do the 3p orbitals and the 4s orbitals. And then we go this way. So we do 3p orbitals, and then we go 4s orbitals, and then we go back to 3d orbitals, 4p, 5s, and 4d, and so on and so forth. So when we look at this chart, the idea is the orbitals have a limit to how much they can take in. So each one of these has a limit to how much it will take in. And therefore, if I'm doing these, I ask myself, how many electrons does the atom have? If it has 2 electrons, then there's just 1s2. If it has 4 electrons, it'll be 1s2, and then I come back around, it'll be 2s2. So if I ask what's the electronic configuration of beryllium, it'll be 1s2, and then 2s2, because it has 4 electrons. What's the electronic configuration of lithium? It'll be 1s2, 2s1 over here. Okay, so that's for lithium. What's the electronic configuration of hydrogen? It was 1s1, and for helium, it was 1s2. So we go 1s1, 1s2, 1s2, 2s1, and so on and so forth. So then what about boron? Well, we've used these two. We've used this two. Now we have to come back to the p orbital. And so for boron, it'll be 1s2, 2s2, 2p1. Now, your textbook describes this in more detail. This would be a good time to read that section in the textbook because it will explain some of the principles in chapter 5 that govern how this is done. The other picture that helps with all of this is when we talk about Pauli exclusive principle and we start drawing these little boxes here. And we draw electron configurations like this. So we have one, if you have 1s1, the electron is going in one direction. If it's 1s2, it will have one going in one direction, one going in the other direction. So this notation here, this part of your chapter, will be a good one to review as well, just for fun. I'm not going into this as much in the test. This is what I'm more concerned with for this particular moment. Finding the electronic configuration of things like neon. This is discussed in chapter 5. So a good reading through chapter 5 will be good for us to prepare for this particular test.